efficiently identify multiple reasons to change in your own code base, you understand the danger of having multiple responsibilities in our methods or classes, and then we see a demo in which we refactor some legacy code and make it adhere to the single responsibility principle. The single responsibility principle has a pretty straightforward definition. Every function, class, or module should have one and only one reason to change. This definition seems pretty simple. However, it might be a little bit abstract. For example, what is the reason to change? Well, in this context, a reason to change is synonym to responsibility. We say that a class which has a single responsibility also has a single reason to change. So we can use these terms interchangeably. Let's take a look at some responsibilities that you've probably seen in your own applications. Business logic is one responsibility. The user interface is another. Persistence, logging are also pretty popular responsibilities. However, things like orchestration are also reasons to change. When you have a component that coordinates other components in order to achieve a particular result, that orchestration is a responsibility in itself. And also people are axes of change, and we'll see an example of this later on. One important habit that you need to develop as a software developer is the ability to identify the reasons to change that your components have, and then to be able to reduce them to a single one. Now that we know what the single responsibility principle is, let's see why we should use it in our code. There are many benefits of using the single responsibility principle. First of all, it makes code easier to understand, fix, and maintain. We spend almost 90% of our time as software developers reading code. It's pretty important to be able to understand it and reason about it very fast, and the SRP has a huge impact on readability. Then, code that respects the single responsibility principle creates classes that are less coupled and more resilient to change. When we are using the single responsibility principle, we keep fragility and rigidity to very minimal levels. And last but not least, we gain a more testable design, which is great from a quality point of view. I'm going to show you a couple of tricks that will help you identify multiple reasons to change in your own classes and methods. And we'll do that by looking at a couple of examples. If statements are a clear sign that a method has multiple reasons to change. We have one reason to change on the if branch and a different reason to change on the else branch. Clearly, this piece of code violates SRP. What we could here, based on the complexity of the logic, is that you could extract the logic for the if branch to a separate method or class, and the logic for the else branch to a different method or class. The same goes for switch statements. Each case represents one responsibility. Again, you can extract them to different methods or classes and make this piece of code more easy to read, maintain, and understand. You should also pay attention to master methods. You can identify them quickly because they have a large number of lines of code, and also they kind of mix the levels of abstraction within the implementation. For example, this method is called getIncome. So by reading the method name, you would expect this method to return the employee income. But when we look at this method, we see that it does a whole lot of things. Indeed, it gets the income from the employee repository. But then it sends that income to the state authority via an API. It generates a payslip. It converts it to JSON, and then it uses that JSON and sends it via email. Obviously, this method does not do one thing. It has many responsibilities, many reasons to change, and it's very, very fragile. Also notice the many dependencies that this method has. In order to do its job, you need to know about the state authority API, the payslip, about JSON format, about the email service. This arsenal of dependencies is also a clear indicator that a method or a component does more than one thing. So each time we see a master method, we need to identify its responsibilities and then split it into multiple methods or even classes that are more manageable and that do just one thing. We saw a couple of methods that have many reasons to change that violate the single responsibility principle. But classes can also do that. Let's take a look at code classes. Do you have projects where you keep helper methods, classes called utils, helpers, shared, or something like this? Well, those are classes that clearly do more than they should. A typical utils class would look like this. You have methods to save objects to database, you have methods for serialization, you have logging in here, you have some friendly dates, helpers, and each time you write a piece of code that needs a place to live, but it's not important enough to have its own class, you'll probably put it in one of these classes. Please don't fall into this trap. Instead, prefer having specialized classes that handle particular use cases. For example, you can have an utility class that just handles dates. You can give it a very meaningful name. Then you can have classes that deal only with serialization, classes that deal only with logging, classes that deal with persistence. Don't put everything in a single class just because it's easier or because others have done it. People are also axes of change in software applications. This method, for example, generates a report that is used by both HR and management. The report is pretty similar to both partners, but at some point in time, HR will want a specific set of features, and management will want a different set of features. Because of those needs, it's far better to separate the report and make a specific report for HR and a different one for management. This way, both reports will have a single reason to change. This is a more subtle case of violating the single responsibility principle. Knowing when people have responsibilities for a piece of code depends entirely up to you and your expertise of the business domain. But it's worth knowing that the single responsibility principle is not all about code. It's also about the actors who use the application. Finally, let's take a look at a piece of code that has a single responsibility. Look at this class. The name is very explicit. This class is called console logger. Very explicit name. Basically tells you that its purpose is to log information to the console. And this purpose is reinforced when we look at the two methods, log info and log error. Of course, this is a very simple and concise example, but this is a feeling that you should have when you're reading a component that has a well-defined purpose. The name should be explicit, the functions and features should be in line with that purpose, and everything should be very, very focused. This is a good example of a class that respects the single responsibility principle. I want to take a couple of minutes and discuss the dangers of writing code that has multiple responsibilities. First of all, that code is more difficult to read and reason about. Remember that we spend 90% of time reading and understanding code, and we should make this process as easy as possible. Also, code that has many responsibilities has a poor quality because testing is far more difficult. Side effects are also a symptom of not using the single responsibility principle. Side effects are basically lies when a function declares it does a particular thing but also does other things internally. Side effects happen, and they are dangerous because most of the time they are hidden. We have to dig in the internals of an implementation to spot it. But the most dangerous symptom of not using the single responsibility principle is usually high coupling. Coupling is the level of interdependency between various software components. Components that have many reasons to change are usually tightly coupled. Coupling with concrete components is especially dangerous because it exposes you to the internal implementation of a particular class. Let's take this example. We have a getIncome method that receives an employee and should return that employee's income. In order to achieve this function, this class has a dependency on the repository implementation, a concrete class. We also declare this repository internally and construct it here. But what happens, for example, when the repository implementation constructor changes? Well, of course, this piece of code will break. This introduces fragility and rigidity in our system. A better solution would have been to create an abstraction for the repository implementation and pass it in as a parameter. In this scenario, the getIncome method is no longer aware of the internals of the repository class and can do its job, get the income for a particular employee. We'll talk more about this technique when we discuss the Dependency Principle. The key takeaway here is that if Module A knows too much about Module B, changes to the internals of Module B may break functionality in Module A. Like I said, this will introduce technical debt. Therefore, you should always pay attention to the dependencies of your particular components and try to extract them and abstract them as much as possible. You should now have a good understanding of the single responsibility principle, but the best way to learn it is by practice. In this demo, we will refactor a component that has many reasons to change. We will use what we learned so far and identify the responsibilities of that component. Then, we'll extract them out by applying the single responsibility principle. The employee class is at the heart of the Pluralsight HR framework and models an employee from a business perspective. You can see common properties like first name, last name, monthly income, and number of working hours per week. But we also have this save method over here. Take a moment to look at this method and try to spot the many responsibilities that it has. First of all, we have a serialization of the employee in order to write it to the file system. That's one responsibility. Then we have a responsibility that deals with file acts. We have logging as the third responsibility, and the overall coordination of these steps, including the exception handling, as another one. Also notice that the save method deals with persistence, but the employee class is a business entity. Therefore, the save method should not even be in this class. We should probably move it to a separate component that handles persistence. So let's go ahead and refactor this method is like this. Let's start by moving the save method out of the employee class. Turns out that we already have a component that deals with persistence, and that is the employee repository. So I'm going to go ahead and paste it as is in the employee repository class. Then we need to fix it by modifying things that don't compile and by using the getters from the employee. I'm going to remove the static modifier. Cool. We have now moved the save method out of the employee, which makes the employee class clean and adhere to the responsibility principle. However, this method still has multiple responsibilities. So let's go ahead and extract them piece by piece. I want to move the serialization logic out of the save method. So I'm going to copy and paste it. And I'm going to create a new class that will deal specifically with employee serialization. I'm going to call it employee file serializer. Notice that the names I'm giving are very explicit, and that will help you keep your classes short and focused. I'm going to create this class, and then I'm going to implement the save method. Now that we go back to the employee, I also want to extract the logging out of the method. I'm going to go ahead, I'm going to create a new class. I'm going to call it console logger, again, a very explicit name, and I'm going to move logging in here. Now, we can come back to the repository and change the implementation. For that, I need a dependency on the new created employee serializer. I'm going to add it here. Notice that I'm injecting the dependency in the constructor so that the employee repository does not have to concern itself with constructing a concrete instance of the employee file serializer. Then I'm going to grab my serialized string by using the newly created serializer. I'm going to remove its whole implementation, and of course I'm going to make the necessary adjustments for this code to work. I'm going to arrange it nice and easy, and we can already see that the save method has grown shorter. We have passed the serialization responsibility to the employee serializer. Now we also have logging and orchestration. It's not a good idea to keep exception handling and logging in the same method. I want to move it out and let the caller handle it. So I'm going to completely remove the logging and the coordination out of this method. In the end, our method should look just like this. The save method is only concerned with saving that employee to the file system. Now that our employee respects the single responsibility principle, let's go to the caller and make the necessary modifications. In our case, the caller is the main method that saves all the employees to the file system, and we need to make it work again. We notice that we can no longer construct the employee repository. That's because the constructor also needs an employee file serializer. I'm going to go ahead, create a file serializer, and inject it in the employee repository. Now that we have our repository, we also need to change the call to the save method, which is no longer happening on the employee class because we have extracted this to a repository. So we will replace this line with repository.save, and we're going to pass in the employee. And now we have to implement the exception handling logic and the logging in here because this is the caller. I'm going to surround the block with a try catch. I'm going to give this exception a meaningful name. In case this fails, I'm going to use the logger class and log this exception. I'm going to use our community create logger to write this exception to the console. For that, we need to instantiate our console logger and use it to print that exception. Console logger write error, and I'm going to pass in a message. I'm also going to pass in exception. And if everything works okay, we still need to do this line. So I'm going to use the console logger and write a message to let us know that the employee has been successfully saved. I'm going to run this application just to make sure that everything still works. We have saved 4 employees, and if we look here, we can see the files where they have been written. Our job here is done. We have successfully refactored the employee save method by continuously applying the single responsibility principle and breaking functionality in specific components where needed. This is a typical process of how you can refactor code to adhere to the single responsibility principle. In this module, we took an in-depth look at the single responsibility principle. We saw how to correctly identify reasons of change in classes and methods. We learned that if statements, switch statements, classes, and master methods are all clear indications that a particular piece of code has many reasons to change, and that we should do our best to refactor it. We then learned about the link between high copying and code fragility. Code that has many reasons to change also tends to have many dependencies, which makes it very brittle. And finally, we learn how to refactor responsibilities out of specialized components in the demo. In most cases, this is a 3-step approach, identifying the reasons to change, extracting them to different components which are specialized, and then refactoring the code so that it compiles and works as expected. To quote one of my favorite books, Dependency Principle, we always want to find components that are self-contained, independent, and with a single and well-defined purpose. That's the essence of the single responsibility principle. We'll take a deeper look at the single responsibility principle. We learn what the